In this video, we're going to talk about the types of chemical reactions. The first one we're going to talk about is a double displacement reaction. And this is a reaction where two ionic compounds react with each other, and the cations and anion partners switch places. Something you need to be aware of is this is referred to as a double displacement reaction, but a lot of times you might see it as a double replacement. They're kind of used interchangeably. So if you're looking at videos on the internet, don't be alarmed if it comes up as different things. Now, this can happen with molecules as well, but it is much more common for two ionic compounds to react in this way. Another way you can see this reaction, the generic form. So we have AX plus BY yields AY plus BX. You might also see this written as AB plus CD yields AD. Now, why did I put A with D instead of A with C and keep it in order? Well, that's because if these are ionic compounds, the cations are given first. And I can't have two cations bond together, they won't be attracted to each other. So the anions are listed second. So I have to put A with D so that I have an cation with an anion. So we'll get AD plus CB. Now, why did I put C first? That is because, again, again, sorry about that. There we go. Again, C is my cation and B is my anion, and I always list my cation first. Now, I had a student once talk about this reaction and describe it as the rainbow reaction, and I really liked that because um, it was just kind of a cute idea. So, when they did this reaction, they looked at it as you can say whoopsies, A going with D, and then C going with B. And then you can draw in our little clouds. See, it kind of looks like a rainbow. Maybe if I actually used rainbow colors, but it's kind of a fun way to remember how this reaction takes place. When you are looking at the types of double displacement reactions, there are two types. The first type is a neutralization reaction. And this is where you have an acid and it reacts with a base. So an acid for this class is defined as something that starts with hydrogen. There is one exception to that rule, and it is the exception of water. Water starts with hydrogen, H2O, but it is not an acid. A base is something that contains hydroxide. So anything that has an acid and a base, it is going to be a neutralization reaction. When you have a neutralization reaction, in a double displacement reaction, the products are always water and a salt. Water and a salt. Remember, a salt is any ionic compound. So let's look at an example of a neutralization reaction. A very common acid is HCl, and a very common base is NaOH. And in fact, HCl is probably one of the strongest acids that we have, and NaOH is probably one of the strongest bases we have. So individually, hydrochloric acid is very dangerous to you. If you get it on your skin, if you ingest it, bad things will happen. You can get acid burns, and similarly, sodium hydroxide, also very bad for you. Now, when these two react, it's going to be this double displacement reaction. So we'll have A, which is hydrogen, going with D, which is hydroxide, and then C, which is sodium, going with our chloride. So seriously, what are our products? We get sodium. Well, we'll start with H, sorry. We'll get HOH plus NaCl. Now, what is HOH? That is just water. And NaCl is table salt. So literally when you take this super strong base and super strong acid and react them together, you get salt water, table salt water. So that's why it's called a neutralization reaction, because you literally neutralize the acid and base and make something that is really benign. The other type of double displacement reaction is called a precipitation reaction. And a precipitation reaction is when you have two aqueous solutions. Aqueous simply means mixed with water. So, for example, sodium chloride is a solid. When I put that in water, it will dissolve, and I have still sodium chloride, but it's not a solid anymore. It's mixed with water, so it is aqueous. So it's when you have two aqueous solutions and they react to form at least one product. And that product that is formed as a solid is the precipitate. So if we look at an example of this, we can look at sodium chloride, and it is mixed with water, so it is aqueous. And we can react that with silver nitrate, also mixed with water, so it is aqueous. This is going to follow the same double displacement pattern. So my sodium will go with nitrate. Sodium is a +1, nitrate is -1. So when I put them together to form this new compound, I just need it as NaNO3 because it's charge neutral as I write it. Sodium nitrate is going to be aqueous. My other product is going to be silver. I know silver is +1 because it's bonded with nitrate, and nitrate is a -1, and I only have one of each of those. It is going to bond with chloride, which is also -1, so we're just going to have AgCl. Now, when this forms, it forms as a solid. So this would be our precipitate, which is given the abbreviation PPT. So this is an example of a double displacement reaction, and the type of double displacement reaction is a precipitate reaction. So when you see that you are starting off with two ionic compounds, they are both aqueous, and it yields a solid product, then you have two types of reactions going on. You have a double displacement and a precipitation reaction. We also have redox reactions, and there are all kinds of redox reactions. Now, redox stands for reduction and oxidation. And in redox reactions, electrons are moved or exchanged between different atoms in the reacting compounds. Oxidation is the loss of electrons, while reduction is the gain of electrons. There are four different types of redox reactions. We have synthesis or combination. Those two words are used interchangeably. Decomposition, single displacement, and again, just like with double displacement, you might see this also as single replacement. They are used interchangeably. And then finally, combustion. So let's look at these all together. A combination reaction or a synthesis reaction. I just want to be very clear about this. This is a combination reaction or a synthesis reaction. It's not really a combination synthesis reaction. They're just kind of used interchangeably. So we have a combination reaction, and that is where two reactants literally combine to make one product. So an example of this might be magnesium reacting with oxygen. And remember, oxygen is a diatomic element, so it has to be O2 to yield one product. So I'm going to combine those two things together, MgO. Now, when they combine, I notice that this is an ionic compound, so I have to make a charge neutral compound. I can't just take the subscripts and put them over here. That's not how this works. When I look at my periodic table, magnesium is in group 2. It's going to have a +2 charge. Oxygen is in group 7, it's going to have a -2 charge. So the charges are already balanced. So if I put a 2 right here, then I would have a compound that is not balanced. So that's why we don't do that. So our balanced chemical formula is MgO. Now I can balance my entire reaction. And I can do that by putting a 2 in front of my MgO to balance out my oxygens. And in balancing out my oxygens, I now have made it so my magnesium is not balanced. So I can put a 2 in front of my magnesium. So this is an example of two reactants becoming one product. In a decomposition reaction, one reactant becomes multiple products. So I start off with one reactant and it decomposes into multiple products. An example of this is sodium carbonate. Sorry, I don't want to use sodium carbonate. We're going to use ammonium carbonate. There we go. And when this decomposes, it's pretty interesting because if you have a container of ammonium carbonate and you open it up, it will just immediately start decomposing. And you will get this very strong smell, which is ammonia gas. And you'll notice that it will start clumping together, and that is because water is formed. And then you can't notice this, you can't really see it unless you do a test, but it also produces carbon dioxide. So here, I know that it produces carbon dioxide because I still have some leftover atoms that I need to use. Now, when I go through and do this reaction, I also have to balance my overall reaction. In my reactants, I have two nitrogen, so I can put a 2 in front of my ammonia. Well, when I do this, it looks like I have now balanced my entire reaction. So sometimes these very complicated looking reactions can actually be pretty simple to balance. In this third reaction, this is our single displacement. And a single displacement is also a reaction of redox. It is a redox reaction. It is where you have one thing, an element, is going to react with another thing, an ionic compound, and the two like ions will switch places. So, what I mean by that is if you have a metal reacting with an ionic compound, then it's going to switch places with the other metal because those are going to both be cations. If you have an anion reacting with an ionic compound, then the or sorry, if you have a nonmetal reacting with an ionic compound, then the nonmetal will switch places with the anion because nonmetals can only make anions. So if we look at a couple examples of this, we can look at zinc reacting with hydrochloric acid. Now, zinc is a metal, so it is going to become a cation. So I have to have it replace the hydrogen because I can't make a compound between hydrogen and zinc. They're going to both have that positive charge. So that means I'm going to have zinc replace the hydrogen. It's going to kick out that hydrogen. And when it does, the hydrogen is going to be by itself. But remember, hydrogen is a diatomic element, so we have to use H2. Now, zinc will always have a 2 plus charge, so in order to make a charge neutral compound, I'm going to need 2 chlorine. Now, I have to balance my overall reaction, and I can do that by putting a 2 in front of the HCl. So this is an example of a metal reacting with an ionic compound. Let's look at an example of a nonmetal reacting with an ionic compound. We can look at the example of sodium bromide, and it will react with chlorine. Now, chlorine is also a diatomic element, so we have to have it exist as Cl2. Chlorine is going to displace bromine because when chlorine becomes an ion, it is an anion. So it has to replace the anion. So when it does that, it's going to kick bromine out and we'll get NaCl. Remember, we can't bring that 2 over because now I don't have a charge neutral compound. Sodium is in group 1, it's a +1 charge. Chlorine is in group 7, it's a -1 charge. So if I have NaCl2, it's not charge neutral. So I have to keep it as NaCl. Then bromine is going to be the thing that is kicked out. Remember, bromine is also a diatomic element, so it has to exist as Br2. Now I can go through and balance my chemical reaction. So in a single displacement reaction, you have to switch the two like ions. Metals will displace metals, nonmetals will displace nonmetals. Finally, we have a combustion reaction. So a combustion reaction is when we have oxygen gas as one of the reactants. And oxygen gas is fire, like literally, it is fire. So this is a burning reaction. When a hydrocarbon, which is a compound made of only hydrogen and carbon, undergoes a combustion reaction, the products are always, always, always going to be carbon dioxide and water. So if you come across an example, and let's say we have butane, C4H10, and it is undergoing a combustion reaction. When you see this, you need to give yourself a high five and just write the products down because you know it is a hydrocarbon. I only have hydrogen and carbon in my reactant. It's reacting with oxygen, so I know my products have to be carbon dioxide and water. Woohoo! I already predicted the products. Now I can just go through and balance my overall reaction. When I go to start balancing out my hydrogen, I notice I have to put a 5 here, which is going to give me a situation where I will always have an odd number of oxygens on my product side, and I will always have an even number of oxygen on my reactant side. So to avoid that, I'm going to double my hydrocarbon. And in doing so, I now have to put a 10 in front of the water. And how many carbon do I have on my reactant side? You got it, 8, which means I'm going to have to put an 8 in front of my carbon dioxide. That changes the number of oxygen on my product side. I have 10 from water and 16 from carbon dioxide, which gives me a total of 26. So the coefficient I need to put in front of oxygen is going to be 13. So this is an example of a combustion reaction. A combustion reaction is a type of redox reaction.